Hello and welcome to Untitled. So today I'm going to be teaching you how to answer the pendulum physics practical questions without performing the experiment. Now, the first thing you have to do is, if this is your first time on this channel, please hit the subscribe button so that you can get other updates, because we are going to be teaching how to perform this experiment without performing the practical and getting the same accurate result those that performed the practical are going to get. Now, the first thing you need to understand is you need to know how the pendulum experiment works. Now, in the pendulum experiment, you need several things. You need a pendulum bob. Now, this is our pendulum bob. Okay, then you need a retort stand. This is our stand. And this is a rope holding our bob. So at this point, we need a meter rule to measure this length and based on what is given. Now, I say suspend the pendulum bob from the clamp as illustrated in the diagram below. Adjust the pendulum bob slightly such that AC, this height, is going to be 90 cm. At this point is 90 cm. So then measure and record time t for 20 oscillations. Now, what it means is suspend the bob a little, slightly displace it. That's displace the pendulum bob slightly such that it oscillates in a vertical plane. So as the bob swings like this, you count for 20 oscillations. And as it goes front and comes back, that's one oscillation. It goes front and comes back, that's two oscillations. You have to count it up to 20. Okay, so it says evaluate, measure and record the time for 20 complete oscillations. Then evaluate t and square root of L. Repeat the procedures for other figures 80, 70, 60, and 50, and plot a graph with t on the vertical axis and square root of L on the horizontal axis. Okay, so now down to our table of values. Now remember, it record that it asks us to perform for 90, 80, 70, 60, and 50. Now this is our time. Now, how are you going to be able to do this without performing the experiment? You need to understand the basis of the pendulum formula. Now, the first thing you need to know in pendulum is that the period t is given by what? 2 square root of L over G. Okay, this is the first thing you need to know. Now, on the basis of this, if you want to perform this without doing the practical, you know that your G, what is your G? G is what? 9.8 meter per second square. Now, in this question, change the value of your G. You can decide that your G is going to be 10.1 meter per second square. Now, this is what we are going to be taking our G at for the purpose of this experiment so that we don't get 9.8. Now, notice if you get 9.8 exactly, someone is going to think you did not do the experiment. But once you get your G plus or minus 0.5, you are in the range, so your result will be accepted. So now we know our G is 10.1. For 90, we are going to do, okay, so at this point, now to obtain our T, our big T, so another thing you have to remember is L, it's in centimeters. So you have to convert, because your G is in meter per second square, your L, you have to convert it to what? To meters. So this is going to be 2 times 3.14 times square root of L. Instead of writing 90 cm, we're going to write what? 0.9 divided by 10. Okay, so let's punch this on our calculator so we'll get our first value. So this is going to be 2 times 3.14 times square root of 0.9 divided by 10. I'll close my bracket. So this is going to give me 1.884. So this is equal to 1.884. So now, I want you to know something. In recording your time, record it to 1 decimal place, because that's the best your stopwatch can do. So this is going to be 1.9. So this is going to be 1.9. So this is for T at T9, at T90, or you call it at T 0.9. Okay, so now to do for t 0.8, I'll perform the same procedure. So this is going to be, instead I'll just come back here and delete and put 8. Sorry, I need to call it back. Okay, so delete, so put 8 here, and I'll get 1.776. So this is giving me 1.776, and that's approximately 1.8. So at this point, I'm going to come here and write 1.8. Okay, so these are the table of values for all my t. Now the next step I need to do is to find my small t, which is, you know that our t is equal to small t over n. Therefore, small t is going to be what? T times n. And you need to know that your n is what? 20. So to perform for the first value, all I need to do, I do that's 1.9 times 20. That will give us 38. So automatically, this is supposed to be read at that's 38 seconds. Okay, so the next one is going to be, we'll bring up our calculator again. So that's going to be 1.8 times 20. And that will give us 36. So this is going to be at 36 seconds. So I'm going to perform this for all my values of small t. So now you can see, without performing the experiment, I've gotten my small t, which means if I was reading my time when the bulb was swinging up and down, I would have gotten 38, 36, 34, 30, and 28. And also, I would have been able to evaluate my t is equal to t over n, which would have divided the 20 oscillations to get 1.9, 1.8, 1.7, 1.5, and 1.4. The next thing says we should evaluate square root of L. So at this point, I'm going to be evaluating my square root of L. So square root of 90. So square root of 90 is going to give us, that's 9.45. In evaluating your square root, make sure there are 2 decimal places. So this is 9.45. So this is 9.45. You can decide to put 0 here to make it uniform. Okay, so the next one will be square root of 80. That's 80. So that will give us 8.94. So this will be 8.94. Okay. So the next one will be square root of 70. At this point, we finish evaluating all our square root of L, and these are our values. So if you check the question, we've gotten everything, all our table of values. We've repeated our experiment for the other values. Now it says plot a graph of t versus square root of L. So all we need to do is, we are going to be plotting a graph of t versus L. So in plotting t versus L, we are going to estimate, because it says determine the slope and evaluate your g. So we're going to plot the graph, we're going to evaluate our slope, and see if we're going to get our g correctly. Okay, so going over to our graph. Okay, so this is our graph which shows t against square root of L. Now, notice our y-axis is carrying our t, which is in seconds, and our scale here, each small box represents what? 0.2. So y here, each small box represents what? 0.5. So we are going to be plotting a graph of t versus square root of L. Now this is where we got our table of values from. So in order to plot this graph, in order to plot this graph, so the first one says 1.9 against 9.45. Now, this is 1, this is 1.2, 1.4, 1.6, this is 1.8. 1.9 is going to be in between here against 9.45. So 9.45 is going to be somewhere before 9.5. So I'll put my dot here. Okay, so the next one says 1.8 against 8.94. So this is 1.8, and I'm going to look for my 8.9. So this is 9. So this is 8.5. So 8.9 is going to be somewhere around here. Okay, so the next one says 1.7 against 8.37. So this is going to be 1.7 is going to be in between here against 8.37. So this is 8 and this is 8.5. So 8.37 is going to be somewhere around here. I'm going to put it here. Then the next one says 1.5. So this is 1.2, this is 1.4. 1.5 is going to be in between here against 7.75. And that is approximately 7.8. So this is going to be 7.5. So 7.8 should be this is 1.5. Okay. So this is 7.5. We'll have our 7.8 to be somewhere around here. Okay. So the next one says 1.4 is 1.2. Now this is 1.4 against 7.07. That's close to 7.1. Okay, so we have 7. So this will be around here. This will be around here. So am I gonna get it? Okay, so these are my dots. So the next thing I'm going to do is to use a straight line to join my dots. Now, you have to make sure at least up to 3 circles are joined in these dots. Now you can see how straight my graph is. So I'm going to continue. Just to make sure it's a straight line. So now you can see my graph. Okay, so at this point, the next question says we should determine the slope. Now, in order to find the slope of your graph, all you need to do is draw what? A triangle. So I'm going to draw my triangle. Draw it to this point. And I'm going to complete it. To this point. Okay, so now this is my triangle. Now the next thing I'm going to do is to trace the dotted lines. These are my dotted lines, so it can enable me evaluate my slope. So this is down here, this comes here, this comes here, down to this place. So now I'm also going to trace the point where it cuts my y-axis. So this is it. So it's at this point, why this is going to be here. So I'm going to trace my lines. To this point. Okay, so at this point, in order to calculate my slope, remember, you have to recall that our slope is going to be change in our y-axis over change in our x-axis, which is going to be change in t all over change in our x-axis is square root of L. So this is going to be, so let's get the change. Now this point, if this is 1.2, this is 1.4, this is 1.6, this is 1.8. So let's call this 1.9. So y-axis is 1.9 minus 1. So let's write that. That's 1.9 minus 1 all over. Then our change in x, it's going to be, this is 9.5 minus 4.8. So it's going to be 9.5 minus 4.8. Now this is going to give us 1.9 minus 1. It's going to give us 0.9 all over 9.5 minus 1.8. We're going to employ our calculator. So this is going to be 9.5 minus 4.8. Now this is going to give us 4.7. Now, okay, so performing this on our calculator, we're going to have 0.9 divided by 4.7. Now this is going to give us 0.191. So this will be our slope is 0.191. Our unit is supposed to be S over cm raised to power half. Okay, you have to remember we did the square root of the cm. Okay, so the next question says we should evaluate g, which is equal to 4 pi squared over x squared. So g is going to be 4 pi squared over s squared. And this is going to be 4 times 3.14 square all over our s is 0.191 square. Now to evaluate this, we're going to punch it on our calculator. So this is going to be 4 times 3.14 square divided by 0.191 square. Now this is going to give us 1081. It's equal to 1081. Okay, 1081. Our unit is not going to be centimeter per second square. So converting back to meter per second square, this will be divide by 100. This will give us 10.81 meter per second square. So this is our final answer of our G. Okay, so with this, you can now see that you can decide not to perform the experiment and you could get your table of values through the back door. One of the things you need to ensure is that your rough work in getting your values are not actually displayed on your answer booklet. So with this, you can solve any practical question on pendulum. Once you understand the basis of the experiment and understand all the formulas, which include the pendulum t equal to 2 pi square L over G and the t is equal to t over n, you can manufacture any figure without performing the experiment. Now, if you think this video is nice, please hit the like button, share it, and don't forget to subscribe because we will be releasing for some other practicals. Now, the last question says, find, let's look at it again. It says, determine from your graph the period of the pendulum for L equal to 75 cm. Okay, so for L equal to 75 cm, Remember, we did square root of L. That was what our graph carried. So let's get the square root of L. So this will be square root of 75. And this is going to give us 8.86 cm raised to power half. So 8.66, sorry. So this is going to be 8.66. Now, we need to read from our graph where our graph is 8.66 and trace it back to the y-axis. So this is 8.5. So 8.6 is going to be somewhere around here. So this is going to be 8.66. It should be close to 8.7. So we're going to trace this down to our y-axis. So this is going to be something like this. Okay. So trace our line. Trace our line down to this place. So at this point, this is 1.2, 1.4, 1.6. This is 1.8. So this is going to be 1.75. Because if this is 1.6, this is 1.8, this is 1.7, so it's in between. So it's going to be 1.75. So T is going to be 1.75 seconds. Now, another way you can verify this is to calculate it. So just remember T is equal to what? 2 pi square root of L over G. So let's punch in our calculator. So when our L is 75, that means T is going to be 2 times 3.14. That will be times square root of, remember our pendulum formula, that's we said it's going to be L over G. Now remember your L, it's supposed to be L is supposed to be 7.5. That's 0.75 divided by 10, because we used 10 in our calculation. Now you can see it's 1.72, which is close to what we got. So you can see that from our theoretical value, it's giving us 1.72, and from our graph, we're getting 1.75. So our answers are close. Therefore, this is the correct answer. Please don't forget to hit the subscribe button and don't forget to like so you can get more videos from us. Thank you.